Today, as we celebrate Children's Day, let's take a moment to recognize the incredible power that each one of you holds to shape the future. Children's Day is just a celebration of dreams, curiosity, and the excitement of discovery, all quantities that are at the very heart of science and technology. Science and technology have brought us inventions that seemed like a magic just a few years ago, from smartphones to rocket, from medical advancements to artificial intelligence. But behind every breakthrough was someone just like you, someone who asked questions, explored, and experimented. Remember, every time you ask why, every time you wonder how, you are taking the first steps towards new discoveries. The future is a place waiting for your ideas and creativity, for your courage to dream big and make things better. As we celebrate today, let's dive into amazing world of science and technology, explore how it touches our lives, and think about how you, the bright young minds here, can change the world through your imagination, innovation, and passion. Today, I want to tell you about something truly special. A young science lover, this child isn't just curious. They have a deep love of exploring how the world works. Whether it looks up at the stars, experimenting with gadgets, or reading about dinosaurs, a child with a passion for science sees every question as an adventure. You are always wondering why things happening and how things work, and they love to experiment, learn, and make discoveries of their own. For a child who loves science, the world is an open book, full of mysteries to solve and exciting phenomena to understand. Who knows? One day, this young scientist might find the solutions to big problems, create new technology, or even make a groundbreaking discovery. A love for science today can shape the world of tomorrow, one question at a time. I'm introducing Master Vidhunandan, Akshamitra Awardee, and author of Eternal Symphony of Cosmos Studying of Class 10th, Government Higher Secondary School, Pulmetahole, Kerala. The topic is Astrobiology and Space Biology. Are we isolated in universe or do we have company? Welcome to Master Vidhunandan. Welcome to Master Vidhunandan. Yes, Vidhunandan is back. Oh, okay. Don't worry, don't worry. Every science week with work with little challenges. Yes, yes, you are into the universe now with a lot of thunders, rain. All right. Yes, go ahead. Yes, yes. Yes, we can hear you. No, it stopped. Screen was stopped. Yes, yes. Yes, continue, continue, continue. Yes, we can hear you. Continue, continue. Okay. Let me check. Let me check. Let me check. I'm opening. Generally, it comes. Let me check. 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 I guess it is coming. I think so. Yeah, yeah. Your voice is audible. Yes, continue. Continue. Yes, please. Yes, please. Oh, let me check. Let me check. Let me check. Okay. I guess it's coming now. Yeah, I guess now it's coming. 1 minute. 1 minute. I'm checking. It is visible to me. Uh, can you can you speak something?
Sir,
Let me check once.
okay, sir, okay, sir.
Maybe my voice, if I speak, it is audible. Your
Okay, sir, okay, sir.
can you speak something? Let me check once. Maybe my voice, if I speak, it is audible.
Sir, sir, I think it is audible now in my phone right here. No, no, sir. It is your voice is only your voice is audible. My voice is still not audible.
Just hold on for some time.
Okay, sir, okay, sir.
Yeah, I guess yours also audible now. Yours also audible now.
Okay, sir. I am audible now. I am audible now. Sir, it is echoing on. Okay, okay. So should I start over, sir?
Yes, continue. No echo now.
So I should start over, right? Most
Yes,
people.
yes, continue, continue.
Okay, sir. Let me start over. Okay, we were just talking about the intriguing topic that is space biology and astrobiology. Right here, we are going to discuss two distinct possibilities. One, we are alone in the universe. Two, we are not. Both are equally terrifying to us, our puny brains, to our squishy brains of Homo sapiens. One, we are floating away in this vast, endless void of space. We are alone in the universe. Two, we are not. Some intelligent alien species out there are observing us with their highly advanced telescopes, and both are equally terrifying to us. And spoiler alert, we are going to discuss only about the possibilities of life outside the Earth. And space biology, we are only going to talk a little about space biology. Space biology is the study of how molecular, cellular, plant, and organism physiology respond and acclimate to space's microgravity environment. When astrobiology is the study of if there is life outside the Earth, if there is extraterrestrial life outside the Earth. Space biology is the study of how is there life outside the Earth. If life is out there, how it can survive. And right now, there are a lot of trends, ongoing trends to space biology and along space biology. And first one is human-centric space biology. Human centric space biology is the space biology research done while considering human physiology and metabolism, whether humans can survive in the harsh environments of space through any type of advanced technological gadgets or anything. And the second one is organism research based on biological modeling. This research is done by employing various model systems that include worms, flies, rodents, rats, etc., etc., etc. And just like astrobiology, space biology is a multidisciplinary approach where the researchers have to have a vast amount of knowledge in astronomy, biology, geography, everything, evolution, etc., etc. And one of the other trends in space biology is plant biology in space. And this is done by seed astroculture or space agriculture, two cool names that we came up with for this very cool experiment. And these two are the main domains in space plant biology. How plants with chlorophyll and other components survive in outer space, harsh environments in outer space. And there is also microbial analysis in space. And this is the research conducted to see if microbes and bacteria can survive in extreme conditions of space. And we almost have an answer to this question, and that is extremophiles, a very peculiar kind of organisms or microbes that can survive in the harsh environments of space. And we will talk a lot about them later, as it is so crucial to learn about astrobiology and space biology through extremophiles. Now, let's jump straight into astrobiology. And unlike space biology, astrobiology can be termed as the study of possible life present in the universe. And this word we should give stress here is possible life. Astrobiology can be termed as the study of possible life present in the universe. And in order to understand the possibility of life in space, we must understand what life is and what are the factors that influence it, how life is formed on Earth, how life can survive on the extreme conditions of space. And that is the basic knowledge that we should have to learn about astrobiology. What is life? Well, life is one of the rarest phenomena in the universe. I mean, out of all the stars in the Milky Way galaxy, out of all these planets in solar system, only Earth, a small blue dot, could acquire the gift that is life. And the conditions of Earth was just right for life to exist. And it is also situated, our Earth is also situated in the Goldilocks zone of the Earth. And it is named after a wonderful story of Goldilocks and the Three Bears, which we will discuss later. And it is the only planet in the solar system with perfect temperature and pressure for life to evolve. And also, it can hold liquid water, which is essential for life. And life evolved from basic building block of life, cells, which were formed by a rare mix of atoms and molecules. I mean, we see the composition of atoms and molecules everywhere in the universe: black holes, stars, nebulas, cosmic clouds, galaxies, etc., etc. But this very composition of atoms and molecules which can form life is very rare, and I think we all are honored to be even alive and talk like this. And let's take a look at the roots of this field, the history of astrobiology. The actuation or the confirmation of the field of astrobiology can be traced to the year of 1953, when two researchers from the University of Chicago named Stanley Miller and Harold Urey conducted an experiment to study the early chemical conditions of the Earth. And these early chemical conditions led to the development of life. Like I said, experiment was a huge success that led to the actuation of the field of astrobiology. That is like And another star is Invitee, which is chemistry, geology, etc., etc. It is a branch created by combining a lot of branches in a tree, a giant tree that is coined this is we call the the planet. Second one, the planetary system the planet is a part of. And the second point is kind of fuzzy because the planetary system the planet is a part of is very important. I mean, our sun is a medium star. Also have a part of a kind of life for their own, just like how we go through different stages in our life: adolescence, childhood, youth, etc., etc., adulthood. Stars also go through this very process, but instead of living 100 years, 1,000 years, they live millions and sometimes billions of years. And that is the very speciality of stars. And the very planetary system, the planet that we are talking about is a part of, is an important parameter for life to exist. And the properties of the star the planet orbits, just like I said before, the star should be a perfect one for life to exist around it. And the distance between the host star and the planet, that is what we can call the Goldilocks zone or the habitable zone of the host star, which we will discuss later. And the presence of crucial elements like carbon, hydrogen, nitrogen, oxygen, etc., etc. And without these elements, life wouldn't form, because these are the most basic building blocks of life, most basic building elements of life. And we don't know about any other composition that might lead to the emergence of life on other planet, but we are made up of these things. I mean, to learn about other things out there, we should know, I mean, if we're to learn if life exists outside earth, we should know what we are made up of, what we are. And we are made up of basic elements like carbon, hydrogen, nitrogen, oxygen, etc. So we think if life should exist outside the earth, their composition should also be this basic elements. And the other one is the temperature. Planet should have the perfect temperature. Global geographic map of Titan that you can see in the left side of the slide. I mean, Titan is the moon of Saturn, one of the moons of Saturn's, which we think might be habitable for life after our sun turns into a red giant. How will a sun turn into a red giant? That's a good question that I asked myself. Every star out there has a lifetime, and they have different life stages that they can go on. Our sun had a main phase, have a main phase, which it is in right now. And after a lot of years, it will turn into a red giant. It will expand. It will engulf the planets towards Mars. It will engulf Mars. And then the habitable zone of our sun will be somewhere else, not where Earth is situated, but somewhere else. And when Sun turns into a red giant, the moon, the satellite Titan, will be in the habitable zone of our sun, and it might be able to hold life. And on the right side, you can see flat crater bottom deposits on Mars surface. Now, let's take a look something that is something are the properties that a planet should have to support life. It is not like the thermophysical parameters like we explained before. This is another properties that a candidate planet should have. I mean, if we are talking about a candidate planet, it should have these properties to host life. First one, the planet is at a habitable distance from the host star. Like I said, it should have a habitable distance from the host star. And second one is star as well as the surrounding three host stars or anything. And the third one is the candidate planet should not have very low mass. It should have the perfect mass, just right perfect mass for life to exist. And the candidate planet should rotate on its axis, and it should also revolve around its host star, like we know about revolution and rotation. The planet must have a molten core. The candidate planet must be able to hold an atmosphere and liquid water. It also must be terrestrial. As I am saying these properties, I would like to introduce to you something that I am most intrigued about, and I have not included those in the slide because it just came to me right now. It is the anthropic principle. Anthropic principle suggests that if universe exists in the way it exists, then one of the most basic properties of our universe should be that an intelligent species like ourselves should be able to ask this very profound question of the universe. And when I'm putting it like that, it might sound a little complicated, but it is complicated for our little Homo sapiens brain to understand. But still, anthropic principles suggest that we are the most basic components of the universe, component of the universe. We, Homo sapiens, the intelligent life form, intelligent species that emerged in a small blue dot somewhere in the corner of the universe. We, Homo sapiens, is what made the universe what it is. And there is a thing called planetary anthropic principle, which suggests that Earth is in a way, like we said, because we exist here on Earth. And we can mix this anthropic principle together with something called fine tuning. We can say fine tuning for life and fine tuning of the universe. Fine tuning of the universe suggests that the universe exists just because all the ratios and all the compositions are just right for it to exist. And fine tuning of life is something that we have explained right here. Everything that is right here on earth is just perfect for life to exist. If the ratio between electromagnetic force and the strong nuclear force were just a little bit different, life wouldn't exist. If the atomic number of hydrogen was a little higher, life wouldn't exist. And all of these composition, all of these components are just right for life to exist, and that is the fine tuning of our earth. Our earth is finely tuned for life to exist. Now, this is a general model of mass energy for habitability. And this model suggests that a planet should have a specific amount of energy with respect to its mass for life to exist. And it suggests that the raw materials that forms life must be present on the planet so that it can assemble and deassemble for the maintenance of life. No matter, it doesn't matter if it is in liquid state, a solid state, gas state, or any other state that we know, but it should be present, and it should be in a way that it can assemble and deassemble for the maintenance, formation, emergence, and survival of life. And as I have said right here on the slide, in other words, the habitability of the planet is proportional to the energy and the mass available for production, development, and maintenance of life. And if there is enough mass on a planet for life to exist, there should be enough energy with respect to this very mass a planet has for a life for a planet to host life. Now let's take a look at something that we have been talking about a lot right now. It is the Goldilocks zone. The very name Goldilocks, come from a fairy tale called Goldilocks and Three Bears. It is a story where a little kind child called Goldilocks meets a family of bears, and these three bears decides to raise it. And birth this Goldilocks want everything in just perfect. The porridge should be in just perfect condition. The bed should be just perfectly fluffy for her to sleep, and everything on that house should be just perfect for Goldilocks. And just like Goldilocks, life, everything, every component should be just right for life to exist. And there is a zone around every star out there that is called the habitable zone or the Goldilocks zone. I don't know why I am so attracted to that name, Goldilocks zone. And if a planet is in this Goldilocks zone, then it is said to have an ability to hold liquid water. And Earth is in the Goldilocks zone of our sun, and that is why our Earth can hold liquid water. But a planet cannot be habitable just because it is in the Goldilocks zone of a planet. It should also have the mass energy model, like we have discussed, and all other parameters, thermophysical parameters that we have discussed before. And there is the funny part about this very Goldilocks zone. And if our Earth were like 1 meters and 7 meters away from where we are right now, life wouldn't exist on Earth, and that is very funny. Just imagine when our Earth formed, an asteroid got hit. An asteroid hit our Earth, and it just moved a little bit, like 3 meters or 7 meters away from its orbit. Then me, you, this presentation, this computer, these books, nothing would have ever existed. And it is so hard, it is so complex to imagine a scenario where life, where humans, where all this technology wouldn't exist. And there is an equation to calculate the Goldilocks zone or the habitable zone of a star, and that is distance. And Hz means habitable zone. Distance is equal to luminosity of the star divided by luminosity of the sun, whole raised to zero point 0.5 astronomical units. One astronomical unit is equal to 1.496 into 10 raised to 8 kilometers. And through this equation, we can find the Goldilocks zone or the habitable zone of any star out there. Only thing we need to know is the luminosity of the star that we are going to take, the candidate star that we are going to check, and the luminosity of sun. Now let's take a look at some very interesting organisms, extremophiles. And the organism, the microbial, or anything as we can call it, you see right here in the slide, is a tardigrade. It is an extremophile that has the ability to survive the extreme conditions of space. I mean, we humans, like I said before, need just the right amount of things to survive here: water, air, gases, elements, everything. We just need the right amount of it so to survive. But extremophiles is not in that way. It's not, they are not created or they are not patterned to be in that way. They can survive in this smooth, silky, cold conditions of Earth, hot conditions of Miami Beach. They can survive in the extreme conditions of space, deep sea, high pressure areas, deep sea, anywhere in the even in the molten core of the Earth, they can survive anywhere. And that is what gives us a hope that there is life out there. Even if there isn't perfect conditions for life to form, there are animals, there are organisms that can survive in the extreme conditions in space where life can never survive. And that is the very speciality of extremophiles. And the discovery of extremophiles is a milestone in the history of astrobiology. And they belong to all domains, biological domains such as archaea, bacteria, and eukarya. And right here is a funny thing that I would like to share with you. And it is a pretty inspiring fact. Pioneer 10, it is a breakthrough spacecraft. It was one of the most influential spacecraft. It was one of the most important spacecraft that human beings has ever launched, just like Voyager. And Pioneer 10 had a plaque inside it, which was a message to the aliens, if there was aliens out there, that we are humans. We look like that, as it says in the plaque. You can see we are humans. We are from a sun. We are from a star called the sun, and as you can see right there in the plaque, there are planets. There is a large sun and planets, and you can see a spacecraft that is being carried away from the third planet. That third planet is Earth, and that spacecraft is Pioneer 10, that just goes out to outside the solar system through the middle of Saturn and Jupiter. And this famous plaque was created by one of my favorite astronomer, astrophysicist, Carl Sagan, the author of the book Cosmos. And there is also a book written by him called The Pale Blue Dot, where he explains how small we are. And just like Pioneer 10, there is a photo taken by the Voyager spacecraft. It is the pale blue dot, which I couldn't include in this slide, but I think it is worth mentioning in this very presentation. Voyager spacecraft just ventured into the unknown, ventured into the void of space as a proof of our existence, as a proof of our intelligence, the intelligence of our brain, something that is inside our head that we don't even think about most of our lifetime. And this very spacecraft journeyed through these planets, journeyed into the space, and it took a photo of Earth. And this is not a dramatic, beautiful photo of Earth that you see on Google Images, Google Photos, Google Earth. It is an image middle of that pitch black. There is a love, everyone you will ever love, everyone that have ever existed, and that is what Carl Sagan says about it. It is an emotional picture, and it does sense a lot of feelings. It asks us, it makes us question our reality, it makes us see everything through a cosmic perspective. And this is what I meant through this presentation. We may be the only life form out there, or we are not. One we are alone, one we are not, gliding through the endless, infinite universe and just gliding through the void. Two, we are not alone, just like gliding through the endless space without knowing another superior species watching over us. And as anything, that might be an extremophile or an intelligent species, more intelligent than us. I mean, there is an equation that suggests that there is almost seven intelligent species in the Milky Way galaxy. We don't even know if we are one of them because we can't scale intelligence because we have intelligence. We don't have intelligence enough to scale intelligence. There might be another species out there that are more intelligent than us. Like Neil deGrasse Tyson says, there is only a 10 percentage of change between the DNA of us and a chimpanzee. But imagine teaching numbers or even letters to a chimpanzee. And imagine if there is a species out there with almost completely different from our DNA, more superior in genetics. I mean, their language, we can't even call it language. We don't know what it is for them. We can't even understand them. That is our property. And here, astrobiology, it is a promising field. It is a multidisciplinary topic, like I said before, where an astrobiologist requires the knowledge about biology, astronomy, astrophysics, and every single science branch out there. And let's hope for it to grow. Let's hope for the new species that we find shouldn't be as terrifying as we think right now, as we imagine right now, an alien with large eyes, large face, eating humans. No, let's just sleep. Let's just sleep knowing that there are two possibilities. And let's just not think of these two possibilities as terrifying. If we are alone, we are just a small speck of dust in the grand dance of the cosmos. And if we are not alone, then there is a species out there for us to be friends with. And to let's hope for astrobiology to grow, for space biology to grow. And I hope all of you have a cosmic perspective to see the universe the way it is, to see the beauty of the universe, the grand dance of the universe. And I hope this lecture, this class was enjoyable. Thank you.
There is so immense pleasure, Master Vidhunandan, about the topic of astrobiology and its very clear structure as a child of 10th standard. As we are the professors, we not expected this. Very big applause to Master Vidhunandan on behalf of our country as well as the students on the occasion of Children's Day. And the information what you given is excellent. Imagine. And I learned a lot in astrobiology, the way the concepts work. Amazing. Dr. Kulkarni sir, any questions from your side?
Yeah, one. Yeah, first of all, let me uh, congratulate Vidhunandan for a wonderful lecture. As Raman said, it's a great thing that you have worked up so much and created visuals and read so many books and prepared. It's a very great thing. It will definitely help you in future. So continue doing that. My question was, are we defining life in the way we understand and then think that we are unique is a question. Life can be much more general than what we are thinking. That is, it is not necessarily based on hydrogen, oxygen, carbon and nitrogen, but some other elements also, possibly. And you see, the way we define life, we may not see it in our neighborhood or even in a distant neighborhood. But if we define life in more general terms, maybe there are any chances or something, is my one question. So, what can be the general definition of life compared to what we are saying? You see, for example, let me give you a thing. We Indians live in a certain way. Okay, the way life is defined in India is different than the way it is defined elsewhere, say in Arabia or in the North Pole, because the temperature conditions are totally different there, not as continuous or as the thing like we have. We have got we have got 6 seasons of three monsoon and this, but in many parts of the world there are no three months. So there the life could be defined in a different way. By the same token, in our neighborhood or even an extended neighborhood, can there be more general definitions of life through which we can see it? Because as we are seeing, we are not getting any life around as much to the extent that the space has been explored. So, what are your thoughts on more general definition of life? Yeah.
So we define life because we know that we are life. I have a life, you have a life. We are the definition of life. So we define the word life through something that we are, what we are made up of, how we survive, and there might be a possibility out there that there are organisms with other composition of elements, with other elements made of other elements. We are carbon-based life forms, and there is a possibility that there are other life forms out there with other elements as their base. But as far as we know, as far as we are concerned, as humans, as not as humans, every single life here on earth is the definition of life. I mean, that is the definition of life.
Mm. Yeah. Yeah, go ahead. Yeah, that's right.
I guess might be there is a signal issue from his end.
is that here we can only collect that much of resources. Okay, sir. We can define life as we want, because there might be people who defines life in a different way than I do or you do or Venkat Raman sir do, and that is based on our misconceptions or our beliefs, our faith. But life is far more than that. It was one of the rarest phenomena on the earth, rarest phenomena in the universe, and we call it that way because we have not found trace of any outside our solar system, even outside Earth, and that is because our limitation in technology. As you said, life might be so general in the universe, or it is not. That is what I said. Two distinct possibilities, and one word that requires stress here is possibility. It is a possibility for life to exist. It is so general in the universe. And one of the other distant possibilities is that life is very rare. Life only exists here on Earth. So, a general definition of life is only possible through what we know about life, what we are. So, according to us, we are the definition of life. And I think that answered your question. Is that clear to you, sir?
Excellent, Master Vidhunandan.
Beautiful.
Thank you, sir.
I guess very thankful to you to come to the session, and we're also hoping the best. Like you, the children, most of the people, if turns into the transparency of science and technology, we are really
Mm,
great teachers. We the
good.
teachers, every time we are looking for your children, and there are the upgradations of the children. And on the occasion of this Children's Day, we are really thankful to you to come to the live and explore about astrobiology and related to astrophysics, where other people can able to learn very easily.
Thank you, sir, for this opportunity.
Thank you so much, Vidhananthan, and thank you, Kulkarni sir, to attend this. We can end the session.
Thank you, sir,
Thank you
for
so
this
much.
wonderful opportunity.